This is the 4.5. These are the last two questions that were on the notes. Mia, I will work this out like on a PDF or whatever, and I'll email it to you. But what I want you guys to have, and you should have this next to you, and I think this will be better. It's a little more organized the way I wrote it like this. There's some really specific things that you need to point out, all right? There's going to be some questions that say, what's the amplitude of this? What's the time period of this? Whatever. But then for the graphing one, there's some really important things that you guys need to know. All right, you need to know the amplitude. That's our A. You need to know the time period that we're looking at. You need to know the phase shift. When I talk about the phase shift, guys, all that's telling you is the starting point. That's not how much you add or subtract to go left and right. It's just the starting point. In order to find the increments that you add, how much to go, how much space is in between each tick mark, that's your time period divided by 4. So we'll talk about that a little bit as we go through here, all right? When I look at this first one, before we even say what A is and all that stuff, let's just look at it. What is 1/2? What do we call that?
Amplitude.
That's the amplitude. That's our range. That's how high and low the graph goes, okay? What is our time period? You can tell me the time period just by looking at this. Can you tell me what the time period is?
X.
What number's in front of X? 1, right? When you have just a 1 in front of your X value, your time period is just 2 pi. Because to figure that out, you say 2 pi over 1. Where does this graph move? Where is this going to start? When I start my graph, where should it start? Is it going to go to the right or to the left? It's going to go to the right, right? This is our shift right here is right, pi over 3. So when I identify our A, our B, our C, and our D, all right? A is my amplitude. We said that was 1/2, right? B is the number that's in front of X, which is 1. C is our phase shift. What did it shift? You guys told me right, pi over 3. So it's pi over 3. And D is going to be, excuse me, our vertical shift up and down. Does this graph move up and down? Are we adding or subtracting anything at the end? No. Okay, good. So our D is 0. So in order to get my graph set up, I need to know my starting point, I need to know the time period, and I need to know the increments. I need to know how far apart each little space is. So in order to find the time period, let's talk about time period. On your little cheat sheet over there, I say over there, it's at the side of the notes, what is the time period? How do you find that out? What does this say? How do you find the time period?
2 pi over B.
It's 2 pi over B. So I'm going to write that out. I'm going to say, okay, my time period is 2 pi over B. In this case, it's 2 pi over what? 1. So my entire time period that we're talking about is 2 pi. Everybody with me on that? Okay, so now we need to find out, well, we can find out a couple things, but we need to find out where our starting point is. Our starting point, it's a little easier to think about it when you have more to work with, but our starting point is going to be, what's the easiest way to say this? Hold on, let me think for a second. Our starting point is going to be our C over B, right? That's what I said. Our phase shift is our C over B, correct? You guys with me? Okay, so try not to zoom out so much so you guys can see better. I'll just write bigger. My starting point, I'll write over here. My starting point is C over B. What is my phase shift? What'd you guys tell me it was? Pi over 3. So it's pi over 3 divided by 1, which is what? So I'm going to start my graph at pi over 3. Does that make sense, everybody? Okay, so here is 0. My first tick mark is going to be at pi over 3. Anybody have questions about how I just got that? All right, now I have to figure out how far apart each of my tick marks is. The way that we do that is we use our increments. I know that my increments, I have to cut it into 4 pieces. So I'm going to say, okay, what is my time period? What's the time period? Okay. So I'm going to take that. This is how I'm figuring out how far apart each tick mark is. 2 pi, whoops, and I'm going to divide that by 4. When I do, how far apart is each increment? Pi over 2. So this is what I'm going to add to every single tick mark to find the next one. If I didn't have a phase shift left and right, and my time period was 2 pi, it would be 0, pi over 2, 3 pi over 2, 2 pi, just all the way around the unit circle. The reason it's not those exact numbers is because we didn't start at 0, we're shifting over. So what I'm going to do is I'm going to take pi over 3, and I'm going to add.
Wait, how did you find the increment again?
You take the time period, which was 2 pi, and divide it into 4 pieces.
Oh, okay.
So to find the next tick mark, I'm going to say, okay, well, I'm going to add pi, so I'm going to take pi over 3, and I'm going to add pi over 2 to it. So would you guys agree with me that a common denominator would be 6, correct? So if I change this to 6, I'd have to multiply by 2, so this becomes 2 pi. If I change this to 6, I got to multiply by 3, so this becomes 3 pi. So the next tick mark right here is going to be how much? 5 pi over 3, okay? So I need another tick mark. How do I find where the next tick mark's going to be?
Miss Meadows, isn't that over 6?
Yeah, I didn't mean to write, yeah. I was looking at the 3. Thank you. You'll see why I wrote that in a second. So 5 pi over 6. So how do I find the next one? I'm going to add, I have 5 pi over 6, right? I'm going to add pi over 3. What would you guys tell me a common denominator is between 6 and 3? It's 6, so 5 pi is going to stay. If I have to multiply this by 2, then I do this by 2, so 5 plus 2 is? Right? Are you guys with me? Hold on.
Yes.
I should be okay now. The increments, we're going to add pi over 2 to each one. So in this case now, I was at, right, 5 pi over 6. So I'm going to add another piece, pi over 2. Common denominator, correct, is 6. So I'd multiply this by 3. Then I get this by 3, correct? So I have 5 pi plus 3 pi gives me 8 pi over 6. Can I simplify that? Which becomes 4 pi over 3. Bella, that's why I wrote over 3 the last time. So I have my next tick mark is 4 pi over 3, okay? How do I find out what that next tick mark is going to be? Add pi over 2 again. So you have 4 pi over 3 plus pi over 2. My common denominator is 6. Good. I'd have to multiply this by 2. So this by 2 becomes 8, right? If I multiply this by 3, this by 3 becomes 3 pi, correct? So I'm left with what? What is it? 8 and 3?
11 pi over 6?
Yep. So this tick mark over here is 11 pi over what? Over 6.
6.
Thank you. Let me erase this a bit. Over 6. So now that we have our increments, now we can do our, if you guys wanted to go another tick mark, you're more than welcome to do one full cycle. If just say we did. All right, let's say we did. Let's go another tick mark. So you can get a full curve. What do I do with 11 pi over 6? Add what? Pi over 2. So common denominator would be 6, correct? This is 11 pi. And then if I multiply this, then I multiply this. So 3 plus 11 is 14 pi over 6, which becomes 7 pi over 3. Pablo, isn't that what you said last one? Totally not related, but that's funny. Okay, so now if I'm going to graph this, I have to look back at the very beginning and say, well, wait, what was my amplitude? What's the highest and lowest that my graph is going to go? 1/2. So if you wanted to, you can say 1 and -1. And then you can mark your half if you want to. Or you could just do half. It doesn't matter. But now let's graph this. So think about this again. This is a sine curve. So am I going to start right on the y-axis, or am I going to start up at the amplitude?
Y-axis.
Sine at y. Write that down. So I'm going to start at y. Now am I starting at 0? Or what's my starting point? Remind yourself again where your starting point was, guys. I start at, look, see, we boxed it out. What do we start at? That was our phase shift. We're going to start at pi over 3. So I'm going to go right here. And it's positive, so that means I go up. Then I'm back at the x-axis. Then I go down. And then I'm back at the x-axis. And then I go back up. And you could do 25 intervals if you wanted to. But your curve, what you need to show me is that you start at the right spot. That's terrible. But start at either the x-axis or the amplitude, depending upon the function that you're using. That you go in the right direction. It's positive, so we started at the x-axis and we went up, then back to the x-axis, then down, then back to the x-axis, then up, and it's just going to repeat itself like that. Questions? Question was, if sine is y, why do you start at the x-axis? Hold on one sec. Important things are to find in order to graph. We have to find the time period that we're working with. We have to find our starting point. And we have to find the increments in between, right? Those are the three like really major things to do. But just looking at this, let's just talk about it for a second. What do you notice right away about this function? It's what? It's a reflection. Good. Since it's cosine, where does cosine usually start? At the amplitude, correct? So I would usually start at positive 3, but this one, I'm going to start where? At negative 3. Okay, good. That's good. Good that you guys see that. So let's talk about our graph and what we have here. My A term, what is my amplitude? Nuh-uh. What is my amplitude? It's 3. It's always the absolute value because that negative has nothing to do with the value of your range. It's telling you that it's a reflection. So B. B is that number that is in front of X. What is my B? 2. C is my phase shift from my equation. So it says plus pi over 4. So what am I going to write down that my C is? No, negative. Good. Negative pi over 4. And then D is my vertical shift. Where am I moving this thing up and down? Am I moving it up and down? What am I adding or subtracting at the end of this function? 0. It's not moving up and down. So think again about the... Hold on one second. Do what? Correct. At the outside of the parentheses. So the things that are important are the time period, the increments, and my starting point. So the first thing I'm going to find, and you guys can write it out like this, is the time period. All right, my time period that I'm going to be working with. How do you find the time period? It's 2 pi divided by b, correct? So I have 2 pi divided by 2, which gives me pi. So my time period is pi. Everybody with me? Time period? Yes.
Yeah.
All right, so let's do the increments next. That's a very logical step to go to next. How much space is going to be in between each tick mark? How do we find our increments? We say the time period divided by what? 4. So it's pi divided by 4. That means I'm going to add pi over 4 to every single thing. If I was going to draw my graph to the left, to the negative side, then I would subtract it. But in our case, we're just going to add. We're just going to always move towards the positive. So now the last really important piece of information to find is our starting point, right? So our starting point, we'll do it in purple. Our starting point. Look on your little tiny cheat sheet. How do you find your starting point? your phase shift. It's C divided by what? B. So I have C, which is negative pi over 4, divided by B, which is what? 2. So this is the same as negative pi over 4 times what? 1/2. So I'm going to start where? Negative pi over 8. If I have these 3 pieces of information, guys, you can really get a good picture of your graph. If I go to graph this, where's it going to be easiest to see? I'll go down here. All right, my starting point, we just said, is negative pi over 8, correct? Now, how do I figure out where I put the next tick mark?
Add pi over 4.
I'm going to add the increment, which is pi over 4. So I'm going to say negative pi over 8 plus pi over 4. I got to get a common denominator. So if this becomes an 8, this becomes a 2, correct? So negative pi plus 2 pi is positive pi over 8. Agreed? Okay, so this is at positive pi over 8. Now I need to find my next tick mark. Well, how do I find the next one? I take positive pi over 8, and what do I add to it? Pi over 4. Good. So I have to get a common denominator. If this becomes an 8, what's the numerator become? A 2. Pi over 4 to change it to 8s. So I have now 3 pi over 8. Agreed? All right, let's do another tick mark. I say 3 pi over 8, and I add another what to it? Pi over 4. So if this becomes an 8, this becomes a 2. So I have 5 pi over 8, right? Let's find another one. If I have 5 pi over 8, and I'm adding a pi over 4 to it, this becomes what? 7 pi over 8. Anybody have questions on how I just found all of my little tick marks, my increments? Anybody? Everybody's okay? All right, now we can graph it. The graphing part is easy once we have all that set. Let me extend this a little bit. All right, what did we say at the very beginning was our amplitude? Okay, it's 3. So I'm going to go up 3. I'm going to go down 3. Now think about where our starting point is. First of all, I have a cosine graph. Cosine starts at the amplitude, right? So I would normally start at 3. But since the original equation is a reflection, where am I going to start? At the bottom, at negative 3. So I'm going to put my first point here at negative pi over 8 and negative 3. Now the next point, guys, where is my next tick mark? It's at pi over 8. It's not at the origin. A lot of you will make a mistake and put a point at the origin. That's not an intercept for us. Our next tick mark is where your next point goes. It's going to be right here on the x-axis. Then at 3 pi over 8, I'm way up here at 3. Then at 5 pi over 8, I'm back down at the x-axis. Then at 7 pi over 8, I'm back down here at my negative 3. And then I just connect a nice smooth curve. And I kind of get all the dots. But I cannot iterate to you or reiterate to you enough, the 3 most important things to find would be your time period, then your increments, and you got to find your starting point. The starting point generally is the one that kind of gets us the most because it's moving it left and right. It changes things a little bit. But I think, I tried last night, I was thinking, how can I condense this? How can I simplify this more? I think if you just kind of focus on finding those 3 things, then the other stuff kind of falls into place. How do you guys feel? Better than yesterday?
Use mirrors.
Oh, we're done. We're gonna get to. We still have. We're gonna. When we get back from Christmas, we're gonna graph all the 4 other functions. Tangent's totally different. For sure, on your test, you're gonna have a graphing question. All right, so you need to understand, guys, time. I'm not going to give you just, not we, it's not just me, but we're not going to give you just like 4 problems. You know, you're going to have a bunch of problems, and the graphing one is going to probably take you the longest. So the more you practice this, the better that you'll be at it.